If you're doing a two-way ANOVA, there are 3 significant tests that are done. There are 3 Fs that are calculated, 3 p-values that are determined. And all of that is before you do any follow-up tests at all. So you will have a test for the main effect of A, a test for the main effect of B, and a test for the interaction. For any of those effects, whether it's a main effect or an interaction, the test, if p is less than 0.05, tells you that whatever it is significant. So there's a significant main effect or a significant interaction, whatever you're looking at. And if p is greater than 0.05, that means there's no significant main effect or no significant interaction. Now remember, there are 3 tests you're doing. And what you learn about one test has nothing to do with what you might find out about any of the other tests. Those 3 tests are completely independent of each other. Okay, so here is output from one of the two-way ANOVAs that we looked at. So the first thing I'm going to do is look at the p-values for those 3 effects: gender, method, and the interaction. So when I look at these numbers, I can tell that there is a main effect for gender because p is less than 0.05. There is a main effect for method because p is less than 0.05. There is no interaction because 0.062 is not less than 0.05. After you've looked and decided what you have significant, you then need to figure out, do you need follow-up tests, and if so, which one? So the first thing to consider is the interaction significant? If the interaction is significant, you examine the interaction graph. And it doesn't matter, you don't need to do a Tukey follow-up test at all. You just look at the interaction graph. And when you look at that graph, if the standard error bars do not overlap, then that pair of means differs significantly. And I'll show you that in a second. If the interaction is not significant, then ask yourself if one or more of your main effects has 3 or more groups. If you've got a variable with 3 or more groups, then you need to do Tukey follow-up tests. If you've got a main effect that shows a difference between 2 groups, men and women, you don't need to do a follow-up test, because if you know that 2 groups differ, all you need to do is look at the means to figure out how. So if I look at Tukey follow-up tests, which I'm doing because the interaction was not significant, this is exactly like what it is when you do it for a one-way ANOVA. I look at the sig values for each pair, and then look at the descriptive statistics, which I did not copy here, but I would need to interpret how method 1 and method 2 differ, which one's better. I would need to look at the mean for method 1 and the mean for method 2. If the interaction had been significant, then I would not do Tukey tests, and instead, as the second step, would look at this interaction graph. Okay, if we look at method 1, those 2 standard error bars do not overlap. For method 2, they do not overlap. For the control, those 2 standard error bars do overlap, which tells me that for method 1, men have a greater change in GPA than women, so method 1 is working better for men than for women. Method 2 works better for women than for men, and in the control condition, there's no gender difference.